Am I audible till the last row?
Yes, sir.
Okay. So, Professor Behra has given me very difficult task to keep you awake post lunch session. So I will try to make it slightly interesting so that you can understand. See, this course we teach in let's say 28 hours plus 2 hours per week labs. So it is a 3 credit course, and this is to be covered in 25 minutes. So I will try to make justice out of it. But at any point of time, if any student is not understanding any aspect, can straight away ask me. Right? My intention should be whatever I am teaching right now should be understood, and then I will take you through some very interesting kind of products uh, which you may be inspired in the, working in this field later on. So the topic is very simple: coating and lamination. When we teach conventional textile processing, we teach pre-treatments, we teach dyeing, we teach printing, finishing. But we forget, the very important processing treatment, which is called coating and lamination. So both are, having a typical application. And if you look at the auditorium itself, you will find many products. See, this fan is a metallic, right? You have some energy consumption. When it rotates at particular RPM, it gives you, typical kind of air, right? It can be a curved blade, straight blade, multiple blades, multiple engineering aspects are there. But let us imagine it is made up of textile. What will happen? It will save a lot of energy. That is very important thing. You can make it luminescent, you can make it phosphorescent, it can glow in dark, it can be conductive, you don't require wire at some point of time, it can be connected with multiple sensors. So the opportunities are endless. So that's how this topic becomes very important. If you look at the product itself, multiple, the seat covers, whatever sound dampening materials, all are coated. So I will take you through coating and lamination in a quick time. So as a second year BTech student, you must have got this interesting information. What are fibers? What are essential properties, desirable properties of fibers? What is the quality aspect? So people teach you textile testing, and costing is also taught. How much costing is required to prepare a textile product? But forget about this. Right now, these are the only two buzzwords exist in the textile field. One is functional property. So why a textile layer is a basic layer? When we have three basic things, food, shelter and clothing, we always talk about basic things. What is the aim of textile material? Is to protect you from the harsh environment. But remember, the environment itself is changing. CO2 concentration increasing, the area under the forest decreasing, so ecological balance is gone out of order. Now environment is same, but the definition is changing. If you see, earlier days UV light was not coming, ozone layer was thick, but now it is depleted, so UV light is coming. Now what you expect out of textile material is again a protection from adverse climatic condition, but the climatic condition itself is changing, so you require very advanced kind of protection. We have witnessed COVID pandemic, right? We have a barrier material between you and the virus, mask. We have PPE kits. Most of the things are actually coated or laminated. So these are the two buzzwords. One, you talk about functionality. Many speakers talked about functionality, right? And you talk about ecology. We have only one planet right now, Earth. Unless you find some other planet, we have to preserve this planet for future generations. So people say this is not a gift from our parents, but this is a loan from our children, right? We have to protect this planet for coming generations. So sustainability. Now why all these things are coming into picture? Look at your lifestyle. If you do surfing, you will find multiple sales are going on. Myntra sale, Flipkart sale, Amazon sale. You require or not, you will try to refresh your wardrobes. Fashion market, right? The next step, fashion change is you require to change your wardrobes. Now that is called lifestyle. People were talking about 60 years of life, 80 years of life. Now we talk about quality of life. You are sitting here, you should be comfortable, you should get a quality of life. Our lifestyle is changing, and whatever evolution we go through will not leave the layer, right, which you are studying as a textile engineering course, the layer called textile. So when the layer is there, you have to engineer the layer to match the lifestyle. Right now you are sitting in this room, air condition is there. If suppose you are operating air conditioner, who requires air conditioning in this room? Human beings. Chair do not require, table is not requiring, this machine is requiring to certain extent, but unnecessarily we are wasting energy to cool the entire air in the room, right? Can you imagine a textile material which can cool your body? Very simple air conditioner, right? It's a simple engineering. Awareness. If I ask you to draw the structure of coronavirus, everybody will draw, because we have seen multiple figures of coronavirus. This is called awareness. All these things are driving our lifestyle, and the requirements of products are changing. Product is same, we call it textile, but the requirement is changing. So that's why we are moving away from a simple traditional clothing to all these functional materials. Now the question is how to design this. This is a very simple product. You can say this is cotton, process it, dye it. You want fastness good enough, use wet dyes, use reactive dyes, use direct dyes, right? Multiple things are there. You match 3 primary colors to get this final, and then finally stitch it. That is a simple design of product. But see how to design this. Is it the same thing? If this person is wearing cotton shirt, imagine what will happen to the guy who is entering the live fire. This guy working in lab, many chemicals are there. Anything can come in accidental contact with the body. Then what will happen if cotton is there? 70% sulfuric acid, complete charring of the material. It should be engineered. See this guy going in space. Atmosphere is not same, but we have to maintain the atmosphere. So multiple layers. Near the body, atmosphere may be same like Earth. Outside, it might be protective. Some particle or a body is moving, may collide. Protection is required, right? It means we have to engineer this. See this. The pathogens from a patient can do cross-contamination. So one person is coming to hospital with an infection, bed sheets, then blankets, pillows, textile products. They can act as a medium to transfer contamination or pathogen from one person to other person. Do we require advanced material? It means this is very simple traditional textile, but if you look at the examples of other textile products, very advanced. You have to engineer them. Now what is a coated textile? Very simple. This is a textile layer, this is a polymeric layer. One textile at least, one polymeric layer at least. This makes it coated textile. What is laminated textile? Again, the definition taken from some textbook, almost is same. At least one textile, at least one polymer. Now what distinguishes them is, in coating we make the polymeric layer in situ. It means on site. You apply something, after drying it will become a polymeric layer. This is called coating. In lamination, you laminate your certificates. So you have a transparent polyester sheet, you put your certificate inside, right? So there is a separate polymer layer, pre-prepared, separate fabric are there together. This is called lamination. In coating, what do we do? You have a paste, you apply on fabric, put it in drying, so that paste will be cross-linked, all volatiles will go and there will be a polymeric layer formed in situ. on site. This is called coating. Now whatever things which you are using gives us a chance to engineer. See, in traditional textile, we have only textile material. But in coated or laminated textile, how you will engineer textile material? One, textile itself. Second, polymer layer. Third, if you add anything in polymeric layer, that will give you additional properties. Can you imagine a material where you have put sensor inside? That became a part of a textile material. That is sensing your heartbeat, or your blood pressure, or your body temperature, right? How you engineered? By selecting the polymer and by adding some fillers, which can be easily added on textile material. This is where coating and lamination becomes very important. You have multiple things that you can do. Imagine you are having a textile material, you put a thermochromic color, you start from your hostel, the color will be different, come out in sunlight, color of the garment will be different, sit in the classroom, different, evening, you have less light, so color will be different. One clothing material, multiple colors. Can you imagine? Very simple. So there we have opportunity to engineer by using fabric, polymer and fillers. You can select any filler, you can put color, you can put carbon black, you can put graphene, you can put all sorts of protective materials that will protect your textile and will protect human beings. So what is the challenging thing is we are actually preparing new material. One layer out of which is definitely textile, at least one, but we have several components which will make this as a new material. This is not anymore a textile material. This is actually having polymer inside, textile embedded. So that is the beauty. So we require interdisciplinary knowledge. Why you require interdisciplinary knowledge? Because you don't manufacture polymers. We can manufacture textiles, spinning, weaving, right? You make a fabric. But polymer is manufactured by a polymer manufacturer and it will be supplied through drums. You are going to just apply. Do you know what polymer is there? Somebody will tell you this is this polymer. Same is true for textile chemicals. People will tell you this is this chemical, but it may not be there. So there we have to maybe students can answer. Better pay attention. I want to design a flame retardant fabric. Right? Very simple. I have one fabric option, cotton, with LOI of 18. You understand LOI? Limiting oxygen index. You have oxygen plus nitrogen, 18% oxygen, rest nitrogen. In that atmosphere, cotton burns easily, so LOI is 18. I have another fabric, aramid. LOI is, let's say, 30. If you want to prepare flame retardant fabric, which fabric you will select? Aramid is simplest choice. But if you look at costing, aramid is expensive, cotton is cheaper. Can I have coating which will cheaply make it flame retardant? Plus cotton will give comfort. Do you understand? It's not necessary to select that fabric. You can select it for comfort, cotton, and then you apply some layers so that it will not burn. Water repellent fabric. We have cotton and nylon 6 and polythene. Obvious choice is, out of these three, the most hydrophobic is polythene. So cotton may be avoided. Remember, comfort is a typical property of apparel. If you go to technical textile, let's say a curtain is there or blinds are there, comfort becomes, secondary or tertiary property may not be required at all. Do we expect comfort out of umbrella? We don't. Very simple. So there we have to select which one will give us the best thing. So if we want to make umbrella, it might be polythene or nylon 6. So which properties of fabric we want to look? Mechanical obviously, because strength and properties are important. Thermal, if you have polythene with melting point of 120 and if I subject it to a treatment of 150 degrees Celsius, it will melt. So coating will cure at 150, but at that temperature polythene will melt. So we can't select such fibers. We have to also look at chemical properties. When you apply any chemical on fabric, fabric should not degrade. Anything else? If I want to join two layers together, what is the important concept? I have polymer and I have fabric. I want to join them together. What is this called? Coating. Adhesion, right? You might have seen a repairing of cycle tube. You must have seen, right? Yes, if you have puncture in tube, what is done? First, air is filled inside the tube. The puncture location is identified by putting it in water. Bubbles will come out. Then the area is rubbed. Then adhesive is applied. Second, small piece of rubber rubbed again, attached. Why rubbing? Because it gives you a good adhesion. Rough surfaces are having better adhesion properties. So there we have to look at all these properties. Now see, this is picked from some textbook. If I want to select a fiber for a particular application, all properties are taught in your textile fiber course. So we can just refer the chart and select the fiber accordingly. You know the chemical properties of cotton, right? Organic acids, cotton is not affected. Strong acid, mineral acid, it may be charred with 70% sulfuric acid, right? So we know all these properties and accordingly we can select one layer, that is fabric layer. You already know everything about fabric layer. Second layer is polymer. You might have seen such kind of fabrics, right? This is a goods carrier. This is tarpaulin. We cover the inside material with tarpaulin. Very important textile material. So, properties of products which are required should be looked. Let's say there is a rain. So, property required is water repellency, UV light coming into picture, UV protection, microbes trying to grow, antimicrobial properties. You require some properties out of this product. Now, the polymer film is outermost. Outside is polymer, inside is fabric. So properties of polymer we have to see, because when water will come in contact, polymeric layer should not allow it to go inside. UV light coming in, polymeric layer should not be allowing it to go inside. Their blending is also very important. You have to blend polymers together, or you can have multiple polymeric layers. Second, base layer versus top layer is another important thing. At least one polymeric layer means one or more. It can be one fabric layer, 3 polymeric layers, coated fabric, 2 fabric layers, 1 polymeric layer, coated fabric. To qualify as a coated fabric, you want only at least one textile, at least one polymer. It means some layer should be base layer, some layer should be top layer. The base layer should be tacky, means sticky. Then only top layer will adhere, right? So there we have to select base layer and top layer. Accordingly, polymers are selected. Now see, I will not go in chemistry. This is PVC, polyvinyl chloride. If you polymerize CH2CHCl, n times you will end up with polyvinyl chloride. This is silicone, right? Both can be used for this tarpaulin. This can be obtained by using PVC coating or silicone coating. We can also give some similar PVDC coating, but how to select? PVC is cheapest, you can easily apply to get the properties. Silicone can be applied, you can get the similar properties, but you can use PVC in India. The temperature is between 0 to let's say 50 degrees Celsius. Start from winter to summer. But this will not work in Europe. In negative temperatures, PVC becomes brittle. So PVC film will come out. Same product, but when the outside temperature or condition changes, you cannot use one polymer for this, other polymer can go up to -60. Do you understand? Same product, but you have to see what is the condition, what are the properties required. This is acrylic, which can also be applied on this. Acrylic will give transparent film, some will give opaque film, some will give colored films. If I want to put advertisement here, I want to write IIT Delhi here, which should be seen from outside. It means IIT Delhi should be printed. Either this polymer should be transparent, then only I can use printed fabric, then apply this polymer, IIT Delhi can be seen. Or after application of this polymer, I should print. Both way I can see whatever is required. But accordingly, I can select transparent versus opaque versus colored. So there also we have a choice. Multiple polymers are there for coating. This is a natural rubber, this is synthetic rubber. Similar properties are obtained. This is polyurethane, which is used for water repellent breathable coating. If you see, these are two products, both requiring water repellency. This person going out, in case of accidental, there raining, not accidental, now raining can't be predicted, climate change is there. So in case of raining, water repellency is required. Same is this, right? This is in marine environment, protection is required. Both are same. But if you look at this, what is the primary property required? Comfort. In contact with body, comfort is very important. Here, no comfort. All polymers can be applied for the required properties. But if I say comfort, all PU will give comfort. Rubbers will not give comfort. So properties required, water repellency, same. But polymer used is different, right? See the interesting things. Glow in dark, you can see the police written. Even in the, during the night time, you can see a policeman is standing in absence of lighting as well. Awning, flexible intermediate bulk carriers, very simple, blinds and all are having very important concept. How to design this? So this should be glow in dark. So we have typical colors which absorbs light during the daytime, and during the night time they will glow on their own. You don't require any lighting condition later on. You can see from the distance. Do you think this is leather? This one is also leather, right? This one is also leather. I will tell you there is no leather now. All these are artificial leathers, which are all polymers. People will say this is leather belt, but actually that is an artificial leather. Nothing. Polyurethane, very simple polymer. This is also a textile product. If you cut it, you will find a nylon fabric inside. And on the top, we have polyurethane layer. Very expensive products, very cheap fabric. Do you understand? So somebody was talking about startups. You start with this. Very cheap coated fabric, very expensive final product. You provide some brand name. You will make this worth 3,000 rupees. Raw material cost is negligible. Then environment is also important, right? You cannot neglect the environment. So there are multiple things which are required to be considered in chemical processing. I will not go in detail, but recycling is very important. You have to recycle everything. Now when you throw your garment, it will go to a dumping ground. If it is not biodegrading, what will happen? A garbage mountain will be created. Not a good situation. There will be leaching of chemicals. When raining is there, that water will take all chemicals. nearby land will be polluted. Then when a vegetable will be grown, pollution, whatever heavy metals, toxic chemicals may be picked. Who will consume vegetables? So whatever you threw to the environment will come back to you. So that's why recycling and sustainability, two things are actually required. Almost recycling is also a part of sustainability, but we have to recycle the textile products, take out whatever we can take from the material, and you use something which is compostable. You put it in soil, you'll end up with manure, right? You have something, you dump it in the agricultural land, after some time it becomes manure, will provide nutrients to soil. Either you do that or recycle the textile material. This is also true for coating and lamination. So what we do in our group, actually in coating and lamination, we have some research which is done. We have synthesized many things. If you look at sustainable products, enzymes, we have synthesized many dyes. All these colors are new colors, and the advantage of these colors, you apply on textile material, mosquito will not sit, and it is antimicrobial. Until your garment is colored, it will show all functional effects, whether 50 washes, 100 washes, whatever washes. We have also prepared polyurethane, which is actually mosquito repellent. So just coat polyurethane on fabric, it will not allow bacteria to grow, it will not allow mosquito to come in contact. Then we also have synthesized many things, I will not go in detail. So we have prepared PU for coating, polyurethane. A lot of chemistry is there, I don't want everything to be discussed. But the advantage of this is antimicrobial, inherent antimicrobial PU were not reported much. Then on the same chemistry, mosquito repellent polyurethane is also prepared. So when you apply it on any fabric, it will make it, multiple functionalities will be imparted. And these are tested for many washes, and it is not going out. Good or bad, I don't know. Mosquito will not. You can see the mosquito repellence is 100%. Nothing is coming in contact. Nothing was there. We made it till 50 washes. Then we thought, same thing, can we protect some human beings from radiation? When I say radiation, we always talk about light. UV light, IR light, or many kind of things. We said, no, not that. We talk about X-ray. X-rays are high energy. You have more energy radiation. Which one? More energetic than X-ray? Gamma radiation. Very good. We have some more radiations incoming. So the fabric which is coated is also protecting from both kind of radiations, X-ray as well as gamma ray. And the fabric is also flexible. You can bend it, right, like a normal apparel. We have made also silicone kind of softener and coating chemical. No bacteria. Then you have 100% mosquito repellency. This is out of silicone, which we use as softener, right? Silicone softeners to make the fabric soft. Silicones are also used in coating. So when such silicone is applied, no mosquito, no bacteria. Now this question is for students, although the crowd is mixed, the dominant crowd is student, right? So my primary focus is students which are there. Maybe from final year I guess, right? Is it? Or second year? Mix. Okay, from whatever, I want to design this. This is called tent. What are the properties you want from tent fabric? Water repellency, very good. Then water, vapor permeability, air permeability, okay. Air can come in.
Flame retardant.
Flame retardant, very good. Anything else? Do you want UV protection? Do you want sunlight to
UV
come in?
Protection. UV
No.
protection.
Now, which fabric you will select? Flame retardant, 1. Water repellent, hydrophobic, right? Not hydrophilic. Do you want comfort in tent fabric? No. So you can select a fabric which is hydrophobic. Very good. Which polymer? You have PVC, cheaper one. You have polyurethane, mid-range. You have silicone, maybe expensive. You have polytetrafluoroethylene, Teflon, which we use on non-stick. That can also be used, but very expensive. As per the costing, you can select the polymer. How to test whether your preferred is correct or not? Do whatever you have said. Flame retardancy, burn it. Very simple flame retardant test. Water repellency, throw water. Right? At the end, all tests are designed like this. Spray test, rain is coming. Bundesman test, maybe under pressure, or you can have a simple try burning test. Air permeability, you can check. Then sunlight protection, just put it in sunlight. See whether shade is there or sunlight is there. Now what is the role of engineer? I think I have taken time. Is it available? Just 2 minutes. So you must be surprised to know what is the role of engineer in this. What is the role of engineer? Because you are going to become engineer. Remember, this is not a drum. Because all chemicals are supplied to textile industry, whether it is dyeing, coating or whatever, the chemical is coming in the form of drum. But let's say you want PVC polymer. The drum should contain PVC. Do you understand? It means the exact chemistry should be known. So that is the role of engineer. Somebody can fool you saying this is polyurethane and inside product is acrylic. There can be multiple things happening. So don't think this is drum. This is actually a chemistry which is inside. This can be this, this can be this. You have to ensure the proper polymer is coated, the proper dye is applied, the proper finish is applied. This is your role. So see, even if you are on the right path and just sitting there on the path, somebody will crush you. So remember, you have to upgrade yourself, right? So I hope something is understood. Water repellency, which polymer can be used? PVC, very good. Any name remembered? Silicone. Very good. Thank you. So my intention is over. I hope
Thank you, sir. Thank you for the interesting presentation and also for carrying out the responsibility very well of keeping the audience awake. So you were assigned that responsibility and you have done it quite nicely. So may I now move to the next speaker of this technical session. We have among us Professor Dr. Bastian Quattelbaum. He will be talking on digitization technologies in circular business model, enablers versus cost trap. Sir.
Good afternoon. I also tried without the microphone, hoping that this works without anything to see. But anyway, let's start. It will come, hopefully. We talked a lot about techniques, a lot about materials already today, and technologies. I will take you a little bit back further down the line. You already produced everything. You wear and used your clothes already. Now we think how we put it back into the circle. and how maybe digitalization will help us. This is the idea, or maybe not. This is what we have to find out. We are right on. Okay, good. So you know this picture already. All my colleagues had it in their slides. I will also talk about here about efficiency, consistency, and maybe something else. And put myself or the presentation in this context.
Do you need column mic?
I don't need, if you understand me, I don't need a mic. All good. All good for you? Or microphone? Then I take a microphone. Can you understand me?
Better? Good? Okay. Then we try with the microphone. So I think I don't have to tell you too much about linear economy compared to circular economy. The one is just using up the raw material, producing, reusing, and then you put it on the waste. And we want to come in the future to a more circular approach where we use the different materials and products we have in use more often, and hopefully we also find materials which we can recycle or even biodegrade and put them back into the natural cycle. And there are different strategies we could apply or can apply. There's one model from the Ellen MacArthur Foundation, which is quite famous, called the butterfly model. And you see on the left the biological part, which is about, again, putting the material itself back to its original purpose, feedstock, let the material biodegrade. We will not talk about this one today. And the blue side of the butterfly model, you see the technological routes where we try to use the materials within the usage phase more often within the production, but also later on during the use when the end user comes into play. And this is where we're going to focus today. We take the user into consideration and see how can we prolong the life of our materials within the usage phase. We could also take another picture to explain this. These are different waste management strategies. We had Professor Radic this morning who also had the 3R already on his slides. Here you see different ideas from 3Rs to 9Rs, where you could reduce, rethink your usage phase, repair, refurbish, recycle, whatsoever, different strategies. And we will focus on reuse, which is within these different waste strategies, hierarchies, which are elaborated over the last decades. So reuse seems to be an important one because it wasn't picked out the last 50 to 40 years. So what is without our industry? Are we linear or more circular? Again, another picture from the Ellen MacArthur Foundation. Numbers are, I think, from 2022, where you see it looks kind of linear. So we go with 97% new materials into our chain, produce a lot of materials. Closed loop recycle, we are under 1%, and we get 12% out within the cascade recycling where reuse is part of. So at the moment we are still in a linear economy, and we will see or have to see how we can hopefully become more circular. An example from Germany, how it looks in Europe or at our home country, looks pretty much the same. You have production, then retail, then usage phase, and the thickness of the lines more or less tell you what's going on with the material. So we have a quite strong collection scheme in Germany, as well as with the Green Deal, what Professor Eichstätt and Monica presented. We have now thresholds what we need to achieve to collect domestic textile waste, and we, from 2025 to 100%, we should be able to collect. So therefore we have at this point quite good access to used clothes, and out of this, a lot of them go into second-hand, and this is the topic for today. We will talk about circular business model of second-hand clothing. I did a quick research online about thrift shops and online platforms in India. I couldn't validate it. I found one, or some of them. In Europe, US, it's a big thing. Second-hand platforms, and we have a rising market. What you can see here, even though it's not showing too much, but on the y-axis you see billion of US dollars, and on the x-axis different years, and something changed, or seems to have changed after COVID. We see within the forecast for the next 6 years, we see doubling of revenue into second-hand fashion markets. So it's quite a good sign already that this is going to kick off, and it's a good industry to invest in if we want to put it on economical figures, but we do have more the ecological idea on it today. And how does this happen? How do we have the chance to get so much revenue? We have a lot of business models already in place for second-hand market. And you can go to, as I said, to flea markets, you can go to thrift shops, which are donation-based. A lot of in US and UK, for example, we have a lot of donation-based shops which are run by NGOs. We have curated second-hand vintage stores, so stores which are checking for you the clothes, the quality checks, and then putting them into their shops. These two concepts are offline shops, and then we have also different other online possibilities, peer-to-peer online markets where you sell stuff to other people directly, but we also have curated second-hand and vintage online stores similar to the ones which are offline, so people already checking for you the quality and maybe also is it the correct brand or not, or is there frauds going on for you. And we also have decentralized online platforms where a lot of materials from different channels, private channels, backwards logistic channels come in, and you can buy the clothes from these different channels. Looks good, so the foundation is there, but there's still something we can support on and something we can have help with digitalization. And let's see where are the challenges for these ones. So I try to break it down into 6 different topics where maybe challenges can occur. First of all, you get material in, and if I only send you one white shirt, it's quite easy. You don't have to sort anything. If you get the full second-hand collected clothes of daily, a little bit more than one white shirt, and you need a sorting process doing this. And there will be difference between offline and online. If you're a small thrift shop, you get maybe 100 pieces a month. If you are a big online platform, you have all the time around about 300,000 to 500,000 pieces in your platform. So it's way more to do. So you sort out in the first idea, is it good, is it not good? Are there stains on it or something? And then later on you do more thorough quality check for holes or anything else. So this is the second focus point we have. Third point, you are interested authentication. So I don't know, you want to buy a Gucci bag. You want to buy a Gucci, let's assume it. And if you want to buy it, you want to be sure that it's really a Gucci bag. So somebody has to tell you, this is not a fake product, and we need authentication. Next stop, if we want to ramp up the business, we should have a good shopping experience. So you are used to buy online, or you used to buy in the shops you're buying now, and this requirements you have or experience you have, they should be the same as for second-hand clothes, and they have to keep up with this one. Sensorial perception, you buy, it's the same for new clothes or for second-hand clothes. You buy something online, you only have your visual sight, you can't touch. So, if you want to stop returning items back to the shops, we have to increase on this topic and be more perceptual on this topic. And the last topic is market access, market outreach. You can imagine a small thrift shop with some items only is really local, reachable for local people, but maybe they could also offer them to people in another city, and therefore they need a different market outreach or market access as they have today. So from challenge point of view, I tried to do a very qualified investigation and said, okay, sorting for offline shop, no problem. Few items, they can sort them easily. For the bigger online ones, it's a challenge. Quality, again, should be the same. A little bit less for online shop as, for example, for sorting. Authentication, both do have a problem. It's not easy to find out really if it's a fake product or not. Shopping experience, an offline shop has it in its own hands to style the shop as good as any other shop. Shopping experience for online shops can be difficult. Sensorial perception, the same, and market outreach is for both difficult. I would like to take you now on the journey to explain a little bit on these different topics, what is already research for done, and what maybe there are research gaps we could do. Quality check, I already said, especially for online shops with over 200K items in their workflow or even more, it's not yet more possible to do a manual sorting or either a quality check for all these different materials, different styles, different errors and defects. But approaches are already available with first good results. They just need some more improvements. What do we need, or what is required at the moment is a near-infrared technology, for example, finding out which materials are within your clothes which you're finding out, and computer vision for error detection. I only have two pictures with me. The left one is the near-infrared spectrum, now already in research with an additional AI engine on top of it. So the near-infrared spectrography really tries to find out which materials are in. It's something like a stick. You point the stick next to your clothing, and then it's doing an infrared spectrography and telling you which materials are in there. But you can imagine, as we already heard, we very seldomly have mono materials. We very often have blended materials. And then the task becomes more difficult. And we have a lot of different blends, so therefore we don't have a database at place now at the moment to find out all blends, and that's why we run an AI agent over this one to have a better result for sorting these materials. Quality check, you see the picture on the right. Unfortunately, I don't got the video because it was not for public. But you see here a conveyor belt with a camera system. This university from Berlin. They are able to detect over 120 different defects within 16 seconds. for material which runs underneath the camera system, and therefore also the quality check is already on its way. Of course, we have to think about how flat does the clothes need to be placed on the conveyor belt. We have to put them upside down for both sides, but yeah, already the technology is available. So research is on its way, and we can maybe go to the different, the next section. Authentication, we talked about it. We don't want to have fake products. We don't. If you want to buy something, we want to buy the real product. What can we do? One thing is thinking in the future. I can already now in new products introduce some NFC, the near field communication systems within threads and within yarns. So you can read them if you get the material, and then this is kind of protection. But if we want to start the business also for already existing products, we can use, for example, image segmentation algorithms which are on a pixel level. Just two pictures. You see there on the left side, this thread. Within this thread, there's a small sensor in it, a near field communication sensor. These NFCs you may already know from your mobile phones. You can put your mobile phone onto this position, and it will give you back that this is what the product it is. And so this is already, pattern is out. Industry is working on it. You have to put it somewhere in your new clothes, and for the future this will work. Different other companies working on this image segmentation. So you do a picture of your product, you break it down to different pixels, compare it with your original, and AI is running over this topic with pattern making and tries to find out in the database if it's original or not. And also this is working quite well. So these are all topics on the market, and also, to be honest, nothing we are working on. I'd like to show you also something we are working on. This is within shopping experience. As I said, if you buy new clothes online, e-commerce is running since 20 to 25 years. They are way ahead in front of e-commerce for second-hand providers, for example. And you can already find AI-driven fit finders. It's already possible that you have 3D avatars which are wearing digital clothing, which you can run around and see how it fits. And even more, we are now working already for real-time interaction with your own personal avatar, which you can put in an AR world, which I'm going to show you hopefully now in a video. It's unfortunately in German, but I try to, but this computer tries to translate it to you. If not, I'm going to moderate what they are telling me. I'm going to stop here, but I think you got the point. So the idea is really that you have real-time closes with your real-time avatar. You dance with the avatar. This was now presented on a TV, but it's applicable for your mobile phone. You saw the video of the guy who was dancing was with just a standard iPhone 13, which was recording the 3D dimensions and was putting it back on the system. Maybe I stop now the translation here. And this is where industry is now working on and trying to implement, maybe not this, but similar things, so that you can have your fitting room in your pocket with you. I have an app on my phone where I can scan you, get my avatar within 1.5 minutes or even quicker. You upload it to a shop, get the clothes on, and you can see how the fitting is from your living room without going to the shop. And industries are going there, and if we want to let the second-hand business fly, it has to quickly catch up with this topic. The other thing is sensorial perception, and it was all about we want to avoid returns, because it doesn't make sense if I have a second-hand business and it does not fit, I send it back, and if I do this especially for a second-hand shop, it kills the business model at all. That we want to avoid returns. The second reason why we send something back after it's not fitting or maybe fitting, we touch it and we see, oh no, I don't like the touch and feel of this material. And this is also something which we have to work on, and we did kind of a lot of investigation how to transfer the message of the feel of touch within a visual channel. First idea is of course always, oh, let's buy a new, or let's invent a new device which can simulate haptics, but this is not scalable and way too expensive. That's why we try to find out how can we transfer the message of haptics or touch within the digital channels. What we did a lot of studies letting people compare material physically, and then we presented them different kind of pictures online, just as flat pictures, and had different categories where they had to judge on, and then see if they could judge pretty much the same as the one with the physical study. And if you put some brain in it, and within the workshops, and you derive good descriptions, what's behind an attribute, what is describing the material, and how to imagine how to test the material in the physical one, you can get quite good results. And so we had 8 different attributes in the beginning, and without the huge effort, we could easily find out that with 4 out of these 8 attributes, people could easily judge also on a digital channel. We are now working on how do we cover the 4 other ones. So we try to put in videos and other information, and to increase this number from 4 to maybe 6 or 7. Other things, which is maybe a future perspective, we try to predict what the customer may judge. Therefore, with the materials we have in the test here, we tested them within our lab in different categories. You see here 9 different categories, which we tested the materials, and then tried to compare them with the different results of the haptic study, the physical study, and the digital study. I did some statistics. I will jump over these ones. The statistics did different correlation analysis and so on, and found out for 2 out of these 8 attributes, we were able to have a quite good prediction model, which is here this linear regression model. It is only predicting 50 to 55% of the judgment, but it's a beginning. You're destroying something, a digital picture, and try to find out how the experience is, and we already can predict around about 50% of the judgment of the customers. So this is quite good. And coming to the last challenging point, which was the market access and market outreach. This is, we have, I don't know, thousands of thrift shops and second-hand shops, for example, in Germany, and they maybe have a customer access of 5 kilometers around them. But maybe I live in Munich, I see a part in Hamburg which I want to have, I can't buy it. So they should maybe go also online. And of course, a small thrift shop is not able to do this on its own, so therefore it's quite an investment to do. But if they would do this, then they would have the same challenges like shopping experience and sensory perception as the online shops. But there's a new issue which comes across is, if you think about this nice avatar which was dancing real time with me, I don't have any digital model of my second-hand clothes. So I have to digitalize the clothes. And this is what we are working on at the moment. We try to find out an algorithm which is fit for purpose for this different kind of business models to digitalize clothes by pictures in 2Ds. We compare them with cutting models out of our cutting software, run an algorithm which is doing the best match out of it, and then generating automatically a 3D simulated VR model of these clothes, which we then can put on our avatar again, and we close the gap to the shopping experience. And this is one idea we are working on. So, is it now help or burden? I didn't tell much about this one yet, to be honest. Sorting. I already said we are quite ahead with this one. The one is the $1 notes, and one is a brain, so we need people to implement it, and the other one is how does it help us on circular economy. So effort-wise, it's already from technology level quite good. The teaching of the algorithm is in research done already also quite okay. So the first teaching of the algorithm is done. So I would say it's medium effort for money-wise and people-wise, but it will really help. Second one, quality is the same because it's one go, one idea. Authentication, really difficult. We have thousands and thousands of products, algorithms to train, not yet really done. It will be difficult and it will be a challenge. And to be honest, the potential for a second-hand market, it's more for the high-price items, I would say. So therefore, I would not put too much money on this bet to go with it. Shopping experience. You saw the prototype in the video. And we don't need too much AI on this topic. And the good thing, a lot of these elements which we use, for example, are out of the shelf. You just buy them, integrate them. A lot of done already, but will help a lot, especially for checking the fit of materials and finding the right size. Sensorial perception, it is easy to do. It's just, not just, but it's some survey, some questionnaire doing potential fit. Fit is leading. The fit is the leading bit. Touch is coming behind. So it's for me a more moderate impact on the second-hand business model. And last one, market outreach, digitalizing second-hand clothes. We have an idea what we're doing, but we have not yet taught any algorithm, done anything. So this will need some money and some clever brains to do this, but then it will really boost for the second-hand market to put it on online platforms. So to conclude, half an hour, yeah, more or less. So I think still, even though we have to take some money in our hands, digitalization can be a key enabler for a successful second-hand business model. We have to see what the online providers are doing already in shopping experience and follow them, so we have a role model to do. and then try to follow this one, especially on fitting. The bigger the platforms they are, the more sharing of burden we have, especially for shops which want to go into this market. They should put forces together, and then we have a chance with joint platforms to open up the market. And this is it from my side. As I like to have the picture again, as Jo said, we only have one world left and ever had, and therefore this is one way to keep it or to bring it back from 1.7 world into one world. And if you have any questions, feel free to ask them now, or if you want to speed up in time, ask them later when we meet around. Okay? Thank you very much.
Thank you very much, sir, for your valuable insight and for your valuable time. Next up, we have Dr. Soumya Chaudhary. Dr. Chaudhary will be talking on importance of analyzing impact behavior of fiber reinforced composites. Over to you, Dr. Chaudhary.
So, good afternoon. Good afternoon. It's been a while. So many information, so many presentations, and so much to do, to work, to listen. I'm not going to make you bored, but I'm telling you, I have the presentation in a three-categorical way. One for the undergraduate students who are interested to do some research and why we need to study hard, or maybe study for a purpose, for a better future. And another for the master students and for the PhD students who would like to create a scientific footprint in the scientific world and probably to do some innovative which can be create your own future, because there's a lot of job scarcity, but there are ample amount of opportunities if you have a right skill and right preparation. All right. So my presentation is importance of analyzing impact behavior of fiber reinforced composites. Professor Rajesh Kumar Mishra from Czech Republic and Professor Vike Behera, who was my PhD supervisor, they've already introduced to you about composites and gave you some lectures on that. And I will just carry forward about the importance of it and some of the applications. A very shocking picture. I don't know how many of you actually were born before 2001. I think very few numbers. So there was a wonderful plane, it's called Concorde, which could take you within 3.5 hours from Europe to USA, mostly from London to New York, which usually takes 9 hours to go. And it was catastrophically damaged because of this small metallic spread was found on the takeoff area, and where the Concorde tire got attached with, and the fragment of those Concorde tire hit the Concorde fuselage and oil tank, which was manufactured some sort of composite materials and metallic combination, and then it caught fire. 113 people were died. There were 109 passengers with 4 air crews. And if you see how much we are using fiber reinforced composites, started from 1950 to till 2020, I don't have the recent, I tried my best to get a result from 2024, but still not available. So if you see a lot of airplanes, which probably you have taken so far during your life, Boeing 737, 787, and the double-decker 380, 350, they're all more than 50% of the material right now, they are manufactured by fiber reinforced composites. And if you see, the Airbus 350, which is one of the most fuel efficient in the aviation industry, manufactured more than 60, you can say that 60, more than 60%, means between 55 to 60% material is fiber reinforced composite. And per seat, they are saving 25% of carbon emission. Less carbon emission than the conventional. If you see an average car, if it's manufactured with steel with less carbon fiber reinforced composites than other materials, it costs you 900, almost 1,000 kilograms. But if it is from carbon fiber reinforced, it's 70% less weight, and it's like half of the overall weight. So its fuel efficiency has been increased a lot simultaneously. We can save a lot of money out of it. And most interestingly, the electric vehicle, where they are facing a lot of problems, especially for the mileage, because they cannot go more than 60, 70, 80, 100 kilometers. So the intercity connection, if you want to go from Bhiwani to Delhi, you probably need to charge in between, but we can probably solve it if it is manufactured in a very lightweight way where the mileage will be more increased. If you see how we actually develop composite structures for advanced engineering, first we think about what kind of textile reinforcement we will be using as an alternative of the metallic parts, and then we evaluate their performance to different mechanical properties, because we cannot just make something in composites and then it gets damaged, and you see there will be catastrophic and human life will be lost. So we cannot take it as a chance. So in that case, we first evaluate their mechanical properties both in in-plane and out-plane, and then based on our demand, we'll go back again to the design process to see whether the structure could be manufactured by hollow structures, structure could be manufactured by like trapezoidal structures, honeycomb structures, like to make it more lightweight, reliable, with enhanced impact energy absorption quality. Later on, we think about how we can use more sustainable material, how can we make the process more sustainable, and then, in that case, we try to introduce some 3D oven structures, and finally, we want to play with the technology to manufacture 3D oven reforms, that how we can enhance the mechanical properties. So, as all of us, we know that textile reinforcement, they can be divided into natural and synthetic. Of course, so far, we have been constantly using for advanced engineering application synthetic materials. However, it has a very, very, I would say, biased idea that why we can't use a natural fiber like jute or sisal or something else in our composite material. We can do it. Obviously, we have to be selective where it would be used, what kind of damage it will be experienced in its service life, so that it can withstand with its quality, with its safety and security. Textile structures, reinforcement structures, can be manufactured in 2D and 3D way, and obviously in weaving, knitting, non-woven, and also in a braiding way. You saw this morning, they showed hydrogen vessel, which can be actually manufactured by 4 or 5 axis of mode in CNC machine, the vessel through braiding technology. However, today I will only focus on the weaving technology, as that's my area of expertise. You probably understood, as I was a student of Professor Behra, so we worked relentlessly for 5 years, from 2019 to 2024, in our Focus Incubation Center at IIT Delhi for manufacturing 3D open structures. So what is the motivation of 3D open structures? From the picture you can see the motivation, as Professor Behra mentioned in one of the junction sign, that you can actually get a very near net shape structure through this 3D weaving. And the benefits of it, you don't have to ply, stitch, or join. Means it's a very heterogeneous while it's manufacturing. So it has a better structural integrity. In addition, it can save a lot of time if we make the whole near net shape as we are desired for our particular application. And these are the classification of 3D open fabrics. You can see they are widely classified. There's a trapezoidal structures, honeycomb structures, sandwich structures. There's a structures with dome shape. Professor Bushgan mentioned this morning as well about it. There is a structure called nodal structure at the extreme right. So you can see that a wide range of structures actually can be developed from 3D weaving. So there is a significant opportunity that we have, that we can play and we can create our imagination and bring it into the reality in the lightweight structures by 3D woven. So what is the difference? A lot of people talked about it. I would like to show you a very simplistic way. The difference between the 2D and 3D structure is the conventional 2D structures, they're stacked one after another. And the 3D structure is, there's a stuffer and there is weight, which you can easily identify, but this binder yarn, the red color yarn, which I mentioned into this one, that's the most important one, because it's actually through thickness directionally is going in a very homogeneous way throughout the structure, so they are inseparable to each other. So today, if you see, I will talk about mostly the solid structures, means a single fabric system, the constituent yarns of which are supposedly disposed in a 3 perpendicular way, x, y, and z direction. However, we can actually play with the solid structures based on their true thickness reinforcement movement. Either it can be diagonal, or it can be in a particular angle, or it can be actually done like layer to layer way. However, we will be only talking about right now in the true thickness orthogonal angle interlock structure for my subsequent slides for my research. So how do we do it? First, we do the cross-sectional, and then we try to make a head design out of it, and then we do the peg plan, and after making the peg plan, we put it into our multi-layer 3D weaving machine, which is in our IIT Delhi, and then we get structures like this. Now come to the point, what is the importance of assessment of composites, especially impact assessment. The problem is there are so many ways the composite structures experience the impact. For example, you are using a composite for wing panels for the aviation, and probably during the process, somebody stepped in, somebody dropped a tool, and there is an indentation happen, some sort of crack happen, and these cracks can be very fatal during the service life, although it cannot be seen very easily. And how does impact happen? Impact not necessarily means something has to hit very hard. It can be soft, but still, if anything hits in a certain pressure, a certain force, and then if it damages its body, so kinetic potential energy converted into kinetic energy, and then you feel the impact and damage causes. And there is a wide range of classification of impact velocity. This is also very important. So today I will only talk about low velocity. However, you can see it's categorized into 4: low velocity, high velocity, ballistic impact, and hypervelocity as well. Now the point is how we will evaluate it. So now I'm actually overcome my undergraduate people. Okay, we are engaged, we understand impact is required, but how we would evaluate it? We need to do some sort of assessment to understand that how these structures will be evaluated so that we can get some data and tell the world, tell the people of the manufacturers or the users that yes, this product would be beneficial for your industry. And that evaluation happens in two ways. For example, if it is an out-of-plane impact, then we can use about drop tower impact. If it is an in-plane, then we can talk about isotope which is called pendulum impact process. So what are the parameters of the impact assessment? You've got the impact, then what parameters you would achieve so that you can define regarding the mechanical properties of the structures. Of course, you will get the impact velocity, peak force, peak energy, peak displacement, specific energy absorption, bending stiffness, material constant, ductility index, and impact toughness. These are all important data to take a very conscious decision with a lot of opportunity to evaluate that, yes, whether we should go with this particular structure for a particular application. So how do we calculate? I mean, a lot of things are understood from the picture, but now how to calculate from a graphical representation of material constant. So the force displacement curve, if you see it very closely, you can create a linear diagram, and that red linear diagram gives you the value of how to calculate the bending stiffness, and from the bending stiffness, you can use the formula which is mentioned here, and then you can calculate the material constant. Constant here, don't misunderstood, it's not a constant, it's more like a material factor. Like, for example, if you have 10 different types of woven structures and you want to evaluate their comparability, it is difficult sometimes with a single numerical number to calculate that how we would develop it. So under one condition, if you test the low velocity impact from the force displacement curve, you will get some numerical values, and from that you can understand which structure became better for you. And then the most important point for us, which you forget, because it's very important when you manufacture preform to composites. Means preform means a dry means whatever we are wearing, or 3D woven structures, what you saw in my other slide. It is not composite yet. Composite comes when I infuse another material and combine it, although they are keeping their constituent material properties, but they give, then it becomes composite. And while we make composite, it's very important to understand the open structural inter-EM crossover points, because they play a significant role in the mechanical properties. So here I considered ASTM D7136, which is a very popular impact test from a different range of impact energy, 16 joule to 50 joule. So this is a research methodology idea. Why you need to do it? You need to try into different velocity, how these materials behave, how they will evaluate it. So that's why I chose a range based on my experience and based on subsequent previous testing that yes, I should go for a range between 16 joule to 50 joule for my structures. I'm just showing you a video that how this testing was happened. So a composite was kept underneath, clamped properly, and a free fall hit, and then it was perforated. In some cases it was not. The perforation happened actually in 50 joule, and then we got a lot of data and value from the machine, and after that we did our excavation from the data to understand the mechanical behavior of those composite structures. There is another testing method which is also important for aviation industry, which is compression after impact, because once you damage, for example, one of the birds strikes your wing panels or something, or your fuselage, then will it collapse immediately? So to understand the tolerance of the damage of that particular structure, Boeing started to do this methodology, compression after impact, to understand how long our structures can withstand and how the force, because the composite structures are connected with each other. It's a huge structure, right? An aeroplane, it's not like a small coupon, so it's something hit somewhere, and they are all connected with each other, and how they hold integrity structures or any kind of pressure internally, how the damage is happening, so how much they can withstand during the time so that flight can come safely. That's what shows here. And if you want to do some in-plane testing, why it is important? Because not all the time our composite structures will be impacted in a flat direction. They can be impacted in the edge direction as well. If it is an in-plane or edge direction impact happens, how our structures behave, we can get evaluated from this pendulum impact process. And finally, to understand that how our structure is actually damaged, how far the damage happens. For example, somebody hit me so badly, what we will do? We'll do our X-ray, right? So to see whether fracture happened or not, what kind of fracture happened. So that all things will be done through this non-destructive testing method. And this is the machine that we have in our IIT Delhi laboratory, that is micro-CT scan. Micro-CT scan is computer tomography. You can do the 360-degree of your excavation of your damaged structures, and then you can see that how much it was damaged, and then you can evaluate some of the information, some of the data from it. For this particular research, I used e-glass, and of course it was a standard material from Owens Corning. This is a company, US-based, who supplies e-glass. Hopefully someone of you will take up the startup project and will manufacture a made in India glass fiber for us at some point. Hopefully, let's say that a new day will come. But right now we are mostly using glass fiber which are manufactured either by US or by Europe or China. China is like leading in some way in terms of price comparability. However, we had actually Owens Corning a glass fiber manufacturing facility here in India in Goa. And for the matrix material, I used a made in India matrix. It was made by Atul Industries Private Limited, Maharashtra, and they gave me this Lapox ARL-125, which is a, you can say, wind turbine grade, as well as, to some extent, aerospace grade. And I use these multi-beam structures to make all 6 different types of weave structures. I don't know whether the picture is so visible or not. All 6 structures actually manufactured under the same gram per square meter. So the GSM kept same, aerial density is same. However, the binder yarn, if you remember my picture where I showed the true thickness yarn, they actually changed their path. In next 3 slides, we will see that how actually they changed. I think I kept it somewhere. Oh no, sorry. I didn't show the cross-sectional view here. But anyway, it has been published already in Journal of Material Science. Later on, if you go to the Google Scholar, you will get the detailed picture of all these structures. Interesting fact is that there is specifications of manufacturing these, and you need to be very careful when you are calculating the fiber volume fraction, because as we are using 3 different directional yarn system here, X, Y, Z. So you need to understand what is the warp, means when I'm talking about warp, means stuff or warp fiber infection, what is the weft fiber infection, and binder, the true thickness, what is the binder fiber infection. And then we calculated the inter-region crossover points, and through these crossover points, we calculated through this very conventional LCM methodology. You can also use one of the coding once you have decided, okay, this is the way we want to do it, so that I did it for 6 structures. Now I can actually develop a model for doing it for 100 different structures to calculate the inter-region crossover points. And from this oven preform, you see there is another machine. It's called coupon molding machine. It's a vacuum-assisted resin transfer method, where the vacuum actually created, and then the matrix material flowed from one side, and then we developed our composites. Through this process, all of this, you can see this green structure, which is actually a basket structure, mat structure, 3 up, 3 down. It shows superiority among all kinds of older structures. I will not go so deep into it. I will just show you the next one as well. If you see from the velocity versus time, you can see that when the perforation didn't happen, all my cards, the velocity came down below 0. and when perforation happened, it was above 0, so you can understand when the perforation happened, when the perforation didn't happen. Sorry. And interesting path, the velocity versus displacement curve, you can see if it's a parabolic shape, that means no perforation happened. If you see there was a slightly parabolic, tighter parabolic, that means it's an onset perforation happened. I mean, it's not fully perforated yet, but some sort of huge indentation happened into the structures. And finally, when no parabolic sign could form, it means all my data set, so it means that the structure was completely shaped, means completely perforated. You can also calculate specific energy absorption because composite structures, as we are saying, it's an anisotropic materials. It's pretty hard to understand which sample. Probably when you cut through the automatic system, sometimes some mishap happens. So we want to calculate the weight of the sample before we test, and then we divide their weight of the mass based on the energy they have been absorbed, and then we calculate really what structure actually giving us some sort of interesting information that I should use for a particular application where I need a lot of energy absorption. I already explained this, how to calculate the bending stiffness here. And from the material constant value, you can also see the basket structure among all kinds of structures. Let's forget about whatever I told of different structures, but there is one structure showed its high peak, and that is the basket structures. And from the high peak, you can understand that max structures has a very, very superior ability to energy absorption than any of the structures. So the industry, we need to tell them that, look, you should make some max structures instead of these conventional plain or twin structures. From the energy profile diagram, you can also see is the pattern or behavior same. So this data, what I'm showing, so what does it mean about this data? So data is, you can actually tell that if I increase the impact energy where my structures are behaving same, whether they're behaving in a very concave manner from the energy profile diagram, that's the blue one, whether it's behaving in a convex manner. Which should I trust it? So that I will understand, I can take a very informed decision that whether I should take a particular structure for a particular application. Because if there's too much variation happens, that if it is like energy absorption, based on energy absorption, if my structures are not going towards the energy profile diagram, if any of the value could be on the blue line, then I could say that, if this one could be blue line, then I could say that whatever the energy I had provided to the structure, it was all absorbed. So it didn't happen actually that. But how can I say that this structure particularly is a better structure? Because if you see, they are very close to the energy profile diagram. But for the rest, they're pretty far away. So these are for the PhD students who want to probably comprehend the scientifically that how your data should be interpreted and understood so that there is enough scientific evidence for taking informed decision and for also doing the modeling later on, because you need to give a lot of information to them. I will not take too long time, a couple of more minutes, I'm almost done. I'm skipping some of this. This is the ductility index that I mentioned. So this line, till this point, this is the energy initiation happened, there's no major damage, and after that, failure happened. And then the ductility index, so plastically, it was deformed before it's completely failed. You can calculate through this propagation energy and initiation energy. I'm going to skip this compression after impact. I just want to show you the picture. An interesting fact I observed, because of 3D woven structure, as this has a true thickness between the layers, my sample actually couldn't transfer the damage from all the top to the down. I tried to wait till the 50% deflection of the maximum stress, but nothing happened actually. So what I interpreted through these structures, either some sort of slippage happened due to the less thickness, or my binding yarn kind of prevent the crack to move from the top to bottom. So my structures was actually able to withstand, even though it was perforated in a very significant way in the middle. And it happened even for the non-impacted material, you see. It's quite identical, impacted and non-impacted structure. And last comparison that I want to show, the inter-VM crossover points, how it impacts. If you see these graphs, the blue dots, black dots, they represent the drop weight impact. So more inter-VM crossover points, actually black dots are going down, means less energy absorption was possible. And if you see the green one is the isotope energy, the pendulum one, in-plane impact. The more inter-VM crossover points, it's going up. So what's the point? What's the solution? I couldn't find a right solution. So then I decided let's put all together and to understand. So I found these structures, it gave us an optimum solution for the edgewise impact and the out-of-plane impact. These are the some images of X-ray. And you can actually calculate an impact toughness, which is a very interesting part. How to calculate it? The damage that occurred in the transverse direction and longitudinal direction, you calculate their data, and then you calculate what is the impact toughness. Let's say what I'm doing now. A lot of people have a question. I finished my PhD. I joined to Hochschule University of Applied Science. Trying to do something which is called smart interface. Professor Josh Gordon has already mentioned, he's my line manager. So what he said, you created a lot of data, right? I created a lot of data, and then how this data can actually benefit to the people, to the industry. It would be benefited if I can create a knowledge toolbox. Means a box or a platform or interface where these all data will be available to some extent. So that the next researcher who will come to the lab and before doing the design of experiment, before doing any kind of like purchase for material and then do a lot of crazy work, they can take a very informed decision that which direction should I go? Which structure should I develop? And also it will help to the industry if they want to do computational modeling with all kinds of data, because you are being able to grab different types of structures, you know the results, and this information will help you to take some informed decisions. Last, I want to introduce one of our labs where we have this R&D project, X-Lives, which is led by Professor Michael Lieber, and Emma Sharif, she's working as a PhD student over there. I'm kind of attached to them. We are trying to do recycle of the composites, carbon fiber composites. So we got in touch a process how we can actually recycle the epoxy material and get our carbon fiber, but as you know, carbon fiber is very expensive, so that we can use again the carbon fiber, and we are trying to compare the recycled carbon fiber and the carbon fiber that we are using as a virgin. It doesn't have a lot of mechanical differences. So this is the recycling process, you can say. These are some of my publications. What I talked about, you can also find it on Google Scholar. And you can take this picture, scan this code if you want to get in touch with me, either over email or through LinkedIn. I'm always available there. Thank you so much.
Thank you, Dr. Chaudhary, for a nice and eloquent presentation. You have given enough food for thought for the novice researchers and academicians who wish to pursue career options in these lines. So now I invite you all over a cup of tea in the tennis court, for which you have been waiting for quite a long, I suppose. So immediately after the tea break, we have next two talks, which will be the last session of the day. So, and meanwhile, during the tea break, we have poster presentations as well. So if there are some participants for the posters, they can put up their posters there. So all of you are requested to join us for tea, and please make sure to come back within 5 to 10 minutes. Thank you. Thank you.
ओके तो आप मेरे को शेयर कर दीजिए।